2 people died in Plainfield, New Jersey on Monday morning. Their car was swept into Cedar Brook. The water came up that fast. That same morning, more than 60 million people across the Northeast were under active flood alerts. Subway platforms in New York City flooded. A roof partially collapsed at a wholesale club in Ocean Township, while 27 people were still inside. First responders in New Jersey commandeered private vehicles, including a front loader, to reach drivers trapped in water up to their windows. More than 700 flights were cancelled across the tri-state area. At Ronald Reagan Washington National Airport in Virginia and at Philadelphia International Airport, the delays stretch past an hour and a half. And as of this morning, the Weather Prediction Center is not done with us yet. More is coming. And I'm going to show you exactly where and exactly when. This is what the beginning of America's flash flood season looks like in 2026. And I want to be clear about something before we get into the forecast. What happened this past week in New Jersey and New York was not an isolated event. It was the latest chapter in a story that has been building across this country for months. Kentucky lost 4 people to flooding in late June. 3 of them died in Madison County alone. 2 drowned in the basement of a flooded home in Richmond while emergency responders tried to reach them. Tennessee lost a mother who went into rising water to save her son and did not make it out. And 1 year ago this week, 135 people died in the Texas Hill Country when the Guadalupe River crested at 37.5 feet. More than a foot of rain fell in less than 12 hours. The ground, mostly granite and limestone with almost no topsoil, could not absorb a single drop. More than 850 people were rescued in the first 36 hours. 2 people are still missing a year later. I'm Arthur, and this is Sky Space Lab. If you are new here, hit that subscribe button and turn on notifications right now. What I am going to show you in this video is not just what happened last week. I am going to walk you through exactly what the GFS, the European model, and the Weather Prediction Center are signalling for the next 10 days across a very large portion of this country. And there is a piece of this pattern that I think almost nobody is talking about yet. So let's get into the data. Let me start with the 7-day roadmap, because the picture here is actually more complex than most coverage is giving it credit for. Right now, as of this morning, July 8th, 2 separate frontal systems are draped across the country simultaneously. The first is a quasi-stationary boundary running across the northern tier, from the upper Great Lakes westward through the northern plains into the Great Basin. The second is a wavy cold front sagging southward through the mid-Atlantic into the Appalachians. Both of these boundaries are sitting in environments with 3 to 4 standard deviations above normal precipitable water. Both of them are going to keep firing convection in waves over the next several days. And the critical detail, the one the WPC keeps coming back to in their discussions, is that storm motions in this kind of pattern tend to run parallel to the boundaries rather than across them. When that happens, you get training, one storm cell after another crossing the same ground. That is how a 2-inch event becomes a 6-inch event in a matter of hours. Here is the setup for Tuesday, July 9th. The Weather Prediction Center has issued a slight risk, that is level 2 out of 4, of excessive rainfall across the upper Great Lakes and the upper Mississippi Valley. The GFS and the European both show consensus on aerial average totals in the 1 to 2 inch range across this corridor, with localized maxima of 3 to 4 inches possible where that training effect locks in. The cities I am watching most closely on Tuesday include Minneapolis, La Crosse, Green Bay, and the Quad Cities corridor along the Iowa and Illinois border. The boundary is expected to stall longest in that stretch. Saturated ground from last week's events means the flash flood threshold in these areas is lower than it would normally be. A 1-inch rain event in a normal July might cause nothing. A 1-inch rain event on ground that just absorbed 4 inches last week causes flash flooding. Wednesday, July 10th shifts the focus slightly but does not let anyone off the hook. The upper-level ridge currently anchored over the southern United States is going to allow another shortwave embedded in the northwest flow to drop southeast into the Midwest. The Weather Prediction Center has flagged a slight risk of excessive rainfall over parts of the upper Great Lakes and the upper Mississippi Valley again on Wednesday. Minneapolis is in this zone 2 days in a row, so is Madison, Wisconsin, so is Dubuque, Iowa, so is Rockford, Illinois. If you are in any of those cities, check your local National Weather Service discussion every morning this week, not the app forecast, the actual NWS discussion. It will tell you things the automated 7-day forecast will not. Thursday and Friday, July 10th through the 11th, is where the pattern gets significantly more concerning. The WPC Day 3 discussion from Tuesday morning is explicit. Deepening troughing across the Midwest and adjacent areas will shift stronger flow southward into the Central Plains, through the Middle Mississippi Valley, through the Ohio and Tennessee valleys, and into the lower Great Lakes. The WPC has outlined a slight risk of excessive rainfall for the Ohio and Tennessee valleys on Friday and into Saturday, July 11th and 12th. The Appalachians are included in that threat zone. The forecast discussion mentions the possibility of mesoscale convective systems, large organized clusters of storms, developing off the central high plains Thursday night and training eastward into already vulnerable terrain. Here is who needs to watch this the most, heading into the back half of this week. Nashville, Tennessee, Louisville and Lexington, Kentucky. Kentucky just went through devastating flooding less than 2 weeks ago, and several rivers in that state are still running above their seasonal baseline. Charleston, West Virginia, Cincinnati and Columbus, Ohio, Pittsburgh, Allentown and Harrisburg, Pennsylvania, Asheville, North Carolina, a city that experienced extraordinary rainfall during Helene less than 2 years ago, is in the elevated threat zone again. If you live in any of those metro areas and you are planning to be outside Thursday evening through Saturday morning, you need a plan. Know your nearest high ground. Know whether you live in a flood-prone zone, and do not wait for the emergency alert to start thinking about it. The weekend of July 12th and 13th does not offer a clean reset. The WPC has already flagged a slight risk of excessive rainfall across the Ohio and Tennessee valleys and the central Appalachians extending from Friday into Saturday. The same shortwave energy driving Thursday's threat will be slow to exit eastward, and the moisture feed from the south is not going to cut off. Model guidance from both the GFS and the European shows 1 to 2 inch aerial averages across that corridor on Saturday, with localized 3 to 4 inch totals possible in the Appalachian terrain where orographic enhancement kicks in. Western North Carolina, eastern Tennessee, southwestern Virginia, and the West Virginia highlands are all in play. And because the ground in those areas has already been softened by repeated events this season, runoff rates will be significantly elevated compared to a fresh, dry soil profile. Now I want to step all the way back and talk about why any of this is happening. Because the week ahead did not come out of nowhere, and what happens over the next 4 weeks is going to look a lot like this, just with different epicenters. The dominant feature in the atmosphere right now is a broad upper-level ridge anchored over the southern United States. The OAA Climate Prediction Center probabilistic hazard outlook issued this week is explicit. An amplified mid-level high-pressure system is drifting into the Four Corners region. High pressure at upper levels rotates clockwise. The flow on its eastern flank is pulling warm, moisture-laden air up from the Gulf, from the Caribbean, from the subtropical Atlantic. Dew points in Nashville and Atlanta and Charlotte this week are in the low to mid-70s. That is not summer humidity. That is tropical humidity. That is the kind of atmospheric moisture content that allows a storm to produce 3 inches of rain in 90 minutes, without even being particularly well organized. Drop your city in the comments right now. I want to know who is sitting under this ridge and who is in the path of these frontal systems. Because the contrast between the two zones right now is extraordinary, and I think a lot of people in the northeast and midwest do not fully appreciate how loaded the atmosphere above them is. On the ridge side, the south and southeast are dealing with heat indices of 105 to 110 degrees from eastern Texas to the mid-Atlantic coast through most of this week. That is the WPC's own language. Dangerous, with potential impacts to health systems, heat-sensitive infrastructure, and people without adequate cooling. Memphis, Birmingham, Atlanta, Raleigh, you are under the heat dome through at least Saturday, July 12th. On the front side, the Midwest, the Ohio Valley, the Northeast, the pattern is the opposite. Repeated shots of heavy rain as shortwaves rotate around the top of that ridge and punch southeast. AccuWeather documented more than 9 inches of rain in 24 hours just northwest of Des Moines last week. Some western Chicago suburbs picked up 4 inches in a single event. The ground across Iowa, Illinois, Wisconsin, and Minnesota has been absorbing these hits repeatedly. There is nowhere for the water to go anymore. And the National Weather Service office in New Orleans issued its own caution this week. Repeated rounds of rain may increase the potential for ponding on roads and localized flooding all the way through the weekend across the Gulf Coast states. Updated in the last 48 hours, the WPC has also flagged that the frontal boundary draped across the northern plains and upper Midwest is expected to become quasi-stationary through at least Wednesday. Quasi-stationary means it is not going anywhere. It sits. Storms fire along it. They move parallel to it rather than across it, and the same neighbourhoods get hit twice. This is one of the most prolonged and geographically extensive excessive rainfall patterns I have tracked in years. What makes it unusual is not any single event. It is the persistence. The ridge is not moving, the fronts keep cycling through, and the moisture feed is continuous. That persistence has an explanation, and the explanation matters for what comes next. El Niño. The current Niño 3.4 index is approaching +1, which puts us near moderate El Niño status as of early July 2026. Sea surface temperatures south of Hawaii and along the South American coastline are well above normal. The Climate Prediction Center monitoring data is clear. We are in the early stages of El Niño intensification, and it is going to continue through the summer. What does El Niño do to the summer pattern across the continental United States? It enhances the subtropical jet stream across the southern tier. That enhanced jet acts like a moisture conveyor belt, pulling oceanic moisture from the East Pacific and the Gulf Basin continuously into the southern United States. It loads the atmosphere with precipitable water, and it tends to suppress Atlantic hurricane development, which is a separate story. But for the immediate flash flood threat that is active right now, El Niño is the engine driving everything else. And here is the part that I think is being significantly underreported in the coverage I'm seeing. The NOAA Climate Prediction Center Extended Hazard Outlook issued this week states that the amplified mid-level high is expected to enhance the monsoonal circulation, potentially bringing tropical moisture and a risk of heavy precipitation into parts of the southwestern United States through the second half of July. That means New Mexico, Colorado, Utah, and Arizona. It also means the Texas Hill Country, because Flash Flood Alley sits right at the intersection of the monsoon moisture flowing northeast and the Gulf moisture flowing north. The region that lost 135 people 1 year ago this week is not protected from another event this summer. The atmospheric ingredients that produced July 4th, 2025 are not rare. They are the seasonal baseline for that part of the country. Have you ever seen what flash flood water does to a riverbank? The way it strips everything, deposits debris 20 feet into the trees, leaves a waterline you can see for years afterward? Drop a comment below. I want to know if anyone watching this has been through one of these events personally, because I think the people who have understood the threat in a way that photographs and numbers cannot fully convey. The Guadalupe River at Hunt, Texas 1 year ago rose from 10 feet to 37.5 feet in 3.5 hours. From minor flooding stage to catastrophic stage, a rise of more than 27 feet in 3.5 hours. The first flash flood warning was issued at 1:14 in the morning. Most people in the area were asleep. The river had been calm the day before. Before we get to what you need to do with all of this information, I want to address the mechanism one more time, because I think the physics here is what separates a good forecast from a great one. Upper-level ridges in summer are not unusual. Every July brings some version of a heat dome somewhere in the country. But the ridge we're dealing with right now has a specific character that makes it distinctive. The WPC's extended forecast discussion used the phrase broad upper-level ridging. Not sharp and compact. Broad. That distinction is important. A sharp, compact ridge is relatively easy to break down. A northwest shortwave can dig under it and erode it in 48 hours. A broad ridge acts more like a continental air mass. It is slow to move, slow to change, and resistant to the perturbations rotating around it. The Four Corners amplification the Climate Prediction Center is signaling for week 2 is going to make this ridge even broader and even more entrenched over the southern United States. We are not looking at a quick pattern change here. We are looking at weeks of this setup persisting. Now here is the specific physics of why that broad ridge generates flash flooding on its periphery, while baking its core. The ridge suppresses convection at its center. No clouds, no rain, no relief. That is why Memphis and Atlanta are seeing heat indices above 105 right now. But on the north and northeast flank of that ridge, the upper-level dynamics reverse. Divergence aloft actually enhances low-level convergence and rising motion. Air is forced upward. Moisture condenses. Storms fire. And because the ridge is so broad and dominant, those storms on the northern flank have very little steering flow to push them eastward. They sit in place. They train along the boundary. They dump. That is precisely the dynamic the Weather Prediction Center keeps flagging when they mention storm motions running parallel to the front. When a storm system is moving northeast at 30 miles per hour, It might spend an hour and a half over your city. When that same system is crawling northeast at 4 or 5 miles per hour because the ridge axis is suppressing the steering flow, it can spend 8 or 9 hours over the same geography. Same storm, same rainfall rate, 6 times the total accumulation. That is not a hypothetical scenario. That is exactly what produced 9+ inches near Des Moines last week and 4 inches across the western Chicago suburbs in a single overnight event. Let me now talk about the river situation, because it adds an important layer to everything I have described. The river forecast centers along the Ohio and upper Mississippi are already running elevated stage levels on multiple gauges entering this week. When you stack new rainfall on rivers already running at 70 to 85% of their bank capacity, you compress the timeline dramatically between the start of a heavy rain event and the point at which that river crosses into its flood stage. A river running at 40% of bank capacity can absorb a significant 2-inch rainfall and never leave its banks. A river already running at 80% of capacity can overtop from what would otherwise be a marginal event. Several river systems in Kentucky and Tennessee are in that elevated baseline condition right now. They have not had time to fully recover from the flooding that killed 4 people in late June. The National Weather Service river forecast centers update their river level projections every few hours. If you live near any waterway from the Central Plains eastward to the Appalachians, I would encourage you to bookmark that page and check it regularly through the next 2 weeks. There is also a wildfire dimension to this story that connects directly to the flash flood threat. Colorado's Aspen Acres fire as of July 6th has burned 91,000 acres across Pueblo and Custer counties, with only 12% containment. More than 11,000 people remain under evacuation orders. A large active wildfire does not just destroy structures and vegetation, it leaves behind a burn scar. The heat of the fire drives organic material into the soil, creating a hydrophobic layer just below the surface. Water cannot penetrate it. When rain falls on a burn scar, virtually all of it becomes instant surface runoff. It channels into gullies and canyons at extraordinary speed, picking up ash, charred logs, and rock debris as it accelerates downslope. Post-fire flash floods in mountain terrain can move faster than a person can run. They can arrive with almost no warning because the accumulation of water on the burn scar happens invisibly before the flow appears at the canyon mouth. If the Four Corners monsoon moisture begins pushing north into Colorado over the next 10 to 14 days, as the Climate Prediction Center is signaling, the Custer and Pueblo County burn scars are going to be in the direct path of that moisture. That situation needs to be watched very carefully. Now let me bring everything down to what you actually need to do. Because there is a real gap between understanding that flash floods are dangerous and being prepared for one when it arrives. The National Weather Service data is consistent on this point. 60% of all flash flood fatalities in the United States involve vehicles, not people caught outside, not people in poorly built structures, people in cars. The number one mistake people make is driving into water-covered roads. A standard passenger vehicle can be swept off a road surface by as little as 12 inches of moving water. At a speed of 30 miles per hour, that becomes an uncontrollable situation in under 2 seconds. The phrase is, turn around, don't drown, but I want to give you something more specific than a slogan. If you are driving at night during a storm warning period, and night is when your risk is highest because you cannot see the water depth or how fast it is rising, and you encounter any water on a road ahead of you, stop the vehicle. Back up if you safely can. Find an alternate route or wait for conditions to improve. Do not attempt to judge depth. You cannot do it reliably in the dark in a storm, and the road surface beneath a few inches of flowing water may not even be there anymore. If you live in a basement apartment anywhere in the Northeast Corridor right now, New York City, Philadelphia, Newark, Baltimore, Washington, and a flash flood emergency is issued for your area, move upstairs before you see water. Not when water appears at your door, before. The time between dry floor and unmanageable flooding in a below-grade unit during a 2-inch-per-hour rainfall event can be less than 20 minutes. Flash flood warnings from the National Weather Service typically carry 30 to 60 minutes of lead time. That sounds like sufficient time to act. But flash flood emergencies, the more severe designation, issued when life-threatening flooding is already occurring or imminent, are frequently issued while the event is already in progress. The New Jersey events on Monday moved faster than the warning timeline could fully capture. The Kentucky events in late June hit hardest overnight. In the Texas Hill Country, the first warning at 1:14 in the morning gave the most exposed locations less than 2 hours before the Guadalupe River reached catastrophic flood stage. Lead time is not a guarantee. Your plan needs to exist before the warning is issued, not after it. The seasonal picture heading into the back half of July is not pointing toward relief. The NOAA-CPC Extended Hazard Outlook signals a wetter than normal pattern for the upper Midwest through at least the end of the month. That means we are going to be having versions of this same conversation around July 15th, around July 20th, around July 25th. The geography of the worst impacts will shift as the ridge evolves and the storm track adjusts. But the fundamental conditions driving this pattern, a moisture-rich atmosphere loaded by El Niño and the subtropical jet, a persistent broad ridge that suppresses steering flow on its northern flank, and soil profiles across the Midwest and Ohio Valley that have already been saturated by repeated events, those conditions are not going to change quickly. I have been doing this long enough to recognize when a summer pattern has a character that it intends to sustain. This one has that character. What I'm going to be watching most closely over the next 72 hours is the Thursday shortwave and how it interacts with the frontal boundary as it presses southeast toward the Ohio Valley. Right now, the WPC has that zone in a slight risk for Friday and Saturday. If the guidance tightens in the next 24 hours and the WPC upgrades any portion of the Ohio or Tennessee Valley to a moderate risk, level 3 out of 4, that is the signal that Thursday evening through Saturday morning is going to be a high-impact event for Louisville, Nashville, Knoxville, and Asheville. I will be back with an update video if that upgrade materializes. Make sure notifications are on so you see it the moment it drops. There is one last thing I want to say before I let you go, because I think it is the most important thing in this entire forecast. The 2 people who died in Plainfield, New Jersey on Monday morning were in a car. The 4 people who died in Kentucky in late June were in homes and vehicles. The woman in Tennessee who died on Sunday was trying to pull her son out of a culvert, where the current had taken him. She ran toward the water. Her instinct was to help. These are not statistics. These are the consequence side of what happens when a pattern like this one catches people without a plan in place. The science of forecasting flash floods has genuinely never been better than it is right now. The models are better, the radar networks are denser, the National Weather Service offices are better staffed and better equipped, and people are still dying at the same rates they always have. The gap is not in the data, the gap is in the space between a correct forecast and an individual decision made at 2 in the morning in a car on a flooded road. Flash flood season does not announce itself with a start date. It does not give you a warning that this is the week you need to pay attention. It has already been running since late June across multiple states, and the data for the next 10 days says it is nowhere close to finished. Stay sharp this week, specifically Thursday through Saturday across the Ohio Valley and the Appalachians. Share this video with anyone you know in that corridor, and tomorrow I will be back watching the models. Stay with me on this one.